Hello guys, welcome back to my channel. And on my last video I went through the first topic for IGCSE Physics, which was measurements and physical quantities. And in this video I'll be going through the second one, which is motion. So if you haven't checked out the previous one, make sure to check it out. And if you want the PDF for this chapter, I would link it down below in the description below. So let's start. So in this video, I'll be going through all you need to know for the topic of motion. So I'll be going through all the motion graphs, acceleration, and free fall. So let's get to it. So the first one is speed and velocity. So we need to know the definition and formulas for speed and velocity. So speed is the distance traveled per unit time, and it's represented by the formula speed equals distance over time. So v is the speed, and s is distance, and t is time. So formula is distance divided by time. And velocity is speed but in a specific direction. On the previous video we learned about scalars and vectors. So speed is a scalar and velocity is vector. That's why vector is speed in a specific direction, because it's a vector. And when you talk about average speed, it's the total distance traveled over the total time taken. What do we mean by this? So an object can move at different speed in a period of time. So for example, let's say a car traveled 10 meters per second for the first 5 seconds, and and then it traveled 5 meters per second for the next 3 seconds, and lastly it traveled, let's say, 7 meters per second for the next 2 seconds, and in all this it traveled a distance of 100 meters. So if you're asked to find the average speed for this one, we take the total distance, which is 100 meters, and the total time taken. So in this case it's 5 plus 3 plus 2, which is 8. So it would be 100 meters divided by 8 seconds. So that would give us 12.5. That's the distance. That's the speed of the car. So it might have varying speed, but the average speed is the total distance over the time taken. Now the next one, it's acceleration. So what is acceleration? So acceleration is the rate of change in velocity. It can also be defined as change in velocity per unit time. So we can say it's change in velocity per unit time. That's also another definition of acceleration. So the formula for acceleration is the change in velocity divided by the change in time. It can also be written as acceleration is the final velocity minus initial velocity over the time. This is the formula for acceleration. And this formula can be used on graphs and also in word equations. And deceleration. So deceleration is negative acceleration. So this means that the object is slowing down. So the graph for deceleration would be something like this. A straight line going downwards. This is the speed and this is the time. We'll look into it more later on. So now let's look at motion graphs. The first one is distance time graphs. So the first distance time graph is for a stationary body. So for a stationary body, it's going to be a straight line, a straight horizontal line, which means that the object is at rest. The next one you need to know is for uniform motion or for constant speed. So for constant speed, the graph is going to be a straight line through the origin. The next one is for a non-uniform motion where speed increases. So if it's curving outwards, that means it's accelerating. So in this graph, it's accelerating, or the speed is increasing. So in this graph, speed is increasing. And in this one, where it's curving inwards, that means the speed is decreasing. So the speed is increasing or decreasing because this, in the first one, this curve means the gradient is increasing. So the gradient is equals to the speed of the object in a distance time graph. And in this one, the gradient is gradually decreasing. So if the gradient is equal to the speed, that means the speed decreases as the gradient decreases. So the gradient of a distance time graph represents the speed, as I've said earlier. So how can we calculate gradient? So gradient is the same as the change in y over change in x. It can also be written as gradient is equals to y2 minus y1 over x2 minus x1. So what this means is, let's say we have 2 points. Let's take this graph. So let's say we have 2 points. So this is x1 comma x2, I mean y2, x1 comma y1. This one is x2 comma y2. So if we would like to find the gradient of this, we use this formula, y2 minus y1 over x2 minus x1. So we take the coordinates and substitute into this formula, would find the gradient, which is also the speed. Now the next type of graphs is speed time graphs. And the gradient of a speed time graph represents the acceleration of the object. So the gradient of a distance time graph, that's the speed. Gradient of a speed time graph, gradient of a distance time graph, that's speed. And gradient of a speed time graph, that's the acceleration. And also, we have to consider the area. So the area of a distance time graph means nothing, but the area of a speed time graph represents the distance or the total distance traveled by the object. So there are different type of speed time graphs. So the first one is the straight horizontal line. This shows uniform motion, or when the slope is 0, the acceleration is 0. So this means the speed is constant. So this is constant speed. The next one is a straight line through the origin. This means that it's accelerating. So the slope is constant and it's accelerating. So that means this is constant acceleration. Now, this one, I've mentioned it earlier. This is deceleration. So the slope is negative. That means acceleration is decreasing. So it's called deceleration. And this last one with a curved one, so we can see that the gradient on this one is increasing. So the gradient is the acceleration. So this is increasing acceleration. So increasing acceleration. What makes this one and the second one different is this is constant acceleration. The acceleration is the same throughout. Even though the speed changes, acceleration is the same. But this one, the speed changes, the acceleration also changes because the gradient is curved and it's changing. So as I've mentioned, the area of a speed time graph represents the distance traveled. So for your syllabus, they can give you mainly these 3 shapes. So the first one is a triangle. So if the graph is triangular, we can use the formula area for the area of a triangle, which is area equals half base times height. So in this situation, what we do is The height over here is 20. Height over here is 20. And the base is 10. So we put into this formula, which equals half times 20 times 10. This gives us 100. So the distance traveled is 100 meters. And the second scenario is a trapezium. So there are two ways to calculate this one actually. So the first one, which is shorter, we use the formula for the area of a trapezium, which is height times a plus b. So a is one of the bases and b is the other base over 2. I'll show you how this formula works. So for this, in this scenario, the height is 10. Okay, the height is 16. This distance over here, it's 16. So it's going to be 16 times. So the first base is, let's say it's the lower one, from 0 to 25. So the first base is 25 plus the other base is the top one, which is this one. So it's from between 10 and 20. So that distance is 10. And then over 2. So 25 plus 10 times 16 over 2, that would give us 280. So distance traveled is 280 meters. Now, the other thing we can do is we can divide this into sections. So we have the triangle, and then after that, we have this rectangle, and we also have another triangle. So we can calculate the area for this one. Let's call it A1, A2, and A3. So we can calculate the area for this triangle, for this rectangle, and for this triangle, and then we can just add them up. A1 plus A2 plus A3. So this formula takes a bit of longer time, so you can use the trapezium formula to be more efficient. The next one is one of the simplest ones. It's the rectangle. So the rectangle, the area is base times height, or you can also call it length times width. So for this example, let's say this is 15 and the height is, let's say, 2. So the area under the graph represents this part over here. So it's base times height, which is 2 times 15, which equals to 30. So the distance traveled is 30 meters. So that's how you find the areas for different type of speed time graphs. The next one is free fall. So for any object free falling on the surface of the earth from any height, the acceleration is constant, and it's 9.8 meters per second squared. So let's say we have maybe a bridge, and then from that bridge a stone, a piece of stone, and also a paper are being thrown. So when they're free falling, the acceleration should be 9.81 all the way throughout for the stone, and also 9.81 all the way throughout for the paper. But for your syllabus, it's okay just to have it as 9.8. So the acceleration is going to be constant. But in reality, this is not going to be true because we have air resistance. So due to air resistance, it would not be 9.81. So it's always 9.8 when there is no air resistance. So if this is a situation where there is no air resistance, the acceleration would be constant and equal, which is 9.8. Terminal velocity. So if an object is falling from a height in a uniform gravitational field, so by this we mean that the force of gravity doesn't change. So on Earth, the force of gravity is constant, and it's 9.8. And in the presence of air resistance. So previously, in the previous slide, we looked at without the presence of air resistance. But in the presence of air resistance, there, there are some things that happens. So firstly, the object will increase in speed as the object is falling. Okay, and the next one is as the speed increases, the air resistance also increases. So when the speed increases, the air resistance also increases. So after a while, the two forces balance each other. So the downward force and the resistive force, which is upwards in this case, and the air resistance, they balance each other until the resultant force becomes zero. Then the object will travel with a constant velocity. So if resultant force is zero, that means the object is going to have a constant velocity. So if we have a rock, it's thrown from a really high distance, and then there's air resistance. So as the speed increases, the resistive force also increases. So when the resistive force increases, that means these forces, the downward force and upward force, they balance each other out. So at some point they would be equal. So these two forces would be equal. And after that, the object would just be traveling at a constant velocity. So when there's a constant velocity, that means it's zero acceleration. That's what we mean. And that constant velocity, that zero acceleration, it's what we call terminal velocity. Let's look at the graph for terminal velocity. So this is the graph for terminal velocity. As you can see, it's a curve going inward. So it's a curve with decreasing gradient. So at first, velocity increases. So until this point, or until this point, the velocity increases. So after a while, the air resistance, let's call it that R. So until this point, the air resistance also increases. So when the air resistance increases, the velocity decreases, which can clearly be seen on the graph. And after a while, we see a straight line. So as we learned earlier, a straight line represents constant velocity. This constant velocity is achieved when the downward force is equals to the air resistance. So you should know and understand this graph and how to draw it, because it can come up often. So that was it for this video. I hope you've learned, and we have done everything you need to know for chapter 2, which is motion, according to your syllabus. And I've gone through some topic questions in the previous video, so if you want to check it out, I'll link it down below in the description. And I hope you've enjoyed. So if you've enjoyed and learned, make sure to like and subscribe, and see you in the next one.